before that, while naming the alcohol, we have to do the same thing. First, you have to write the root word. Root word means based on the number of carbon atom, meth, eth, prop, but, pet, whatever it is, you have to write that. Plus, in case of alcohol, the name should end with ol. Okay, so here we cannot write alk, actually it is alken. Means what we are doing here, see, properly I will explain here. Actually what we are doing here is, suppose we have an alkane molecule. So from alkane, this hydrogen is replaced by hydroxyl group. That's how we are getting an alcohol, right? So from the alkane, I am removing E and adding ol. So it will be alkane plus ol. So alkanol. That will be the name method for the alcohols. Then if the hydroxyl group is present at the first carbon, no need to mention the number. If it is at the other carbon, means other carbon, second, third, fourth, we have to mention the number of carbon in which the hydroxyl group is connected. So I am taking one example, propane. Okay, propane means CH3, CH2, CH3. So what I am doing here is, from this propane molecule, I am replacing this hydrogen. So I am getting, now I am going to write the structural formula. So CH3, CH, this is the displayed one. No need to write because you can understand the structural and displayed, right? Okay. So CHOH, CH3. So here the second carbon is connected. See, while numbering the particular compound, the hydroxyl group connected carbon should get the less number. So here the OH group connected carbon is the second carbon. So we will name like this was propane, right? Because only single bonded carbon, so it was propane. So what I am doing, I am removing E. So it will be propan. Now I am putting a hyphen to mention the position. 2 ol, propan 2 ol. If it is in the first carbon, it will be propan 1 ol. So if it is 1, no need to mention, you can simply write propanol. This is the nomenclature. Okay, so this is methanol, methan 1 ol, methanol. This is ethan 1 ol, ethanol. Okay, so this is the nomenclature. If two hydroxyl groups are there, we have to write di. Means ethane 1 2, because suppose in ethane CH3 okay, so in CH3 I'm replacing each hydrogen from both and replacing with hydroxyl group. So this is not ethanol, this is ethan 1 2 diol, because two hydroxyl groups are there. Okay, that's all. Now, moving to the phenol. Okay, phenol, we know the hydroxyl group is connected to one aromatic ring, that is phenol. So, phenol is a simplest hydroxy derivative and it consists of a benzene ring, the term ortho and meta. We know this is normal phenol. So, the adjacent position of phenol is called ortho position, and the next one, that is the second position, is called meta position, and the opposite position is called a para position. So you can substitute the hydrogen from the phenol molecule by using any other group like methyl group, then it will be cresol then ortho, cresol, meta. See, here OH and CH3 adjacent, that is ortho. Because this CH3 is in ortho position, this is meta position, so meta cresol. This is para position, para cresol. Okay, now see, here two hydroxyl groups are there. So this is catechol, resource. They have specific common name, and this is the IUPAC name, benzene 1,2 diol, benzene 1,3 diol. This is ortho, this is meta, this is para. Okay, this is the nomenclature for phenols. And ethers, when you give name to the ethers, alkyl and allyl groups are alphabetical order added either to form ethers, same thing. So here, this is an asymmetrical ether, right? One side is CH3, other side is CH2, CH3. So this compound we can name like methyl ether. Okay, like that. So if the two groups are same, you can add di, means diethyl ether. So you can write like that. Okay.